Hello everyone, this is Dr. O.P. Verma and today we will discuss the basic operations on sets. So first of all, we will discuss the Venn diagram representation of sets. After that, the operations on sets. So we will discuss union of sets, intersection of sets, difference of sets and complement of set. Venn diagram. Venn diagram were introduced in 1880 by Johann Venn. A Venn diagram is a illustration of relationship between and among sets. A rectangle represents a universal set and circle or circles represents a set or subsets. Example, place the elements of sets in proper locations in the given Venn diagram. Given set U and set A. Write a Write a rectangle that represents a universal set and circle inside the rectangle which represents set A. Then write elements of set A inside the circle. Then elements of universal set which is not in A outside the circle. So that you have to write down the elements of universal set which are not element of A outside the circle. In another example, given set U, given set A and set B. Draw the rectangle and two circles inside the rectangle to represent the universal set U and its subsets A and B respectively. Place the elements of A inside the circle A and elements of B inside the circle B. Note that set A and set B have no common elements, so these sets are called disjoint sets. Operations on sets. First operation is union of sets. If A and B are two sets, then union of A and B is a set which consists of all the elements of A and all the elements of B, the common elements being taken only once. The symbol union is used denoted the union. Symbolically, we write A union B and usually read as A union B. So this is the example here. A consists the element 7, 2 and 5 and B consider the element 1, 2, 5, 8. So 2 and 5 are the common elements. So all the common elements will be written only once. So A union will be 1, 2, 5, 7 and 8. 2 and 5 will not be repeated. Example 1. Let A contains the element 2, 4, 5, 6 and B contains the element 4, 6, 7, 8. So then A union B is contain all the element of set A and all the elements set B, but the repeated element will be taken only one. So here 4 and 6 are the repeated element and 4 and 6 are taken only once. So the A union B is 2, 4, 5, 6, 7, 8. So this is also represented by the Venn diagram. So the common element will be represented in the common circle. So 4 and 6 are the common elements. So 4 and 6 are represented in the common area of the both circles. This is the example 2. This example 2 contains if set A contains the element 2, 4, 6, 7 and set B contains the element 6, 8, 10, 12. Then we have to find out A union B. So A union B contains all the element of set A and all the element of set B. But the repeated element will be taken only once. So here 6 and 8 are repeated elements. 6 and 8 will be taken only once. So the A union B will contain the element 2, 4, 6, 8, 10 and 12. Here is another example. If X contains the element A, E, I, O, U and Y contains no element, that is by the empty set. So we have to find out the X union Y. So X union Y, in X union Y we will take all the element of the set X and all the element of set Y. So here Y contains no element. So the A union B will be only the element of X. So that is A, E, I, O, U. So that will be the only X set. So X union B Y will be X set. So here we can say that the union of any set with empty set is set itself. Here are some property of union. let A and B be two sets, then A union B equal to B union A. It is called the commutative law. Second is associative law. And third, if we take the union of any set with phi, we will always get that set. It is called the law of identity. And union of any set with respect to itself it will be the set, again it is called the idempotent law. And union of universal set with respect to set A will be the universal set U. This is called the law of. Here the another example: if A contains the element 2 5 1 2 5 and B contains element 3 4 5 and C contains the element 2 3 6, then you have to verify the associative property of unions of sets. So we have to verify A union with respect to B union C and B equal to A union B with respect to C. So we have to find out first. So here we have A equal to the set A, B and C. So here A union will be contain all the element of A and all the element of B, and repeated element, that is 5, will be taken only once. So the A union B will contain the element 1, 2, 3, 4 and 5. And A union B, if we take union of A union B with respect to C, so we will have all the element of the set A union B and all the element of set B, and repeated element only taken one. So here 2 and 3 are repeated element. So A union B will contain the element 1, 2, 3, 4, 5, 6. Again B we are we will calculate B union C. So B union C will contain all the element of B and all the element of set C, and repeated element will be taken only once. So here 3 is the repeated element. So B union C will contain the element 2, 3, 4, 5, 6. Now we will take the union of A with respect to B union C. So here the B, this will be equal to, and this set will contain the element 1, 2, 3, 4, 5, 6. So here 2 is the common element. So common element 2 is taken only once. So here you can see that if we apply the associative property on 3 of union on this set, it will always verified. So here both the values, that is A union B taken union with respect to C is equal to A union taken with respect to B union C, both are equal. Second operation is intersection of sets. If A and B are two sets, the intersection of two sets A and B is the set which consists of all the elements which are common to both sets A and B. The symbol this is used to denote the intersection. Symbolically we write A intersection B is the set that contains X such that X belongs to A and X belongs to B. Here is the example. If set A contains the element 2, 3, 4, 5, 6 and set B contains the element 3, 5, 7 and 9, then you have to find out the A intersection B. So in these two sets, elements 3 and 5 are common. So the set containing these common element is the intersection of set A and B. That is, the set containing element 3 and 5 will be the intersection of A and B. Here is the another example. Here let A contain the elements from 1 to 10 and B contains the element 2, 3, 5, 7. Then you have to find out the A intersection B, and you have to show that A intersection B equal to B. That means the intersection of A and B equal to the set B. So here the common element both sets are 3, 5, 7. So common elements are 2, 3, 5 and 7. These elements are element of set B and this is the complete set B. So hence A intersection B will contain all the common elements at A and B. So these are the common element in A and B. So the elements are 2, 3, 5, 7. So this is the nothing but this is the set B. So hence true. So here is another example. Set A contains the element ABC and set B is 5 and we have to find out the A intersection B. So here you can see that there is no common element to these two sets since set B is empty. Hence intersection of these two sets will be empty because set B contains no element and we in intersection we will take common element to both sets. So B has no common elements, that means intersection will contain no element. So intersection will be empty. So here we can say that the A intersection B equal to 5, then A and B are said to be disjoint. Disjoint means they don't have the common element. Here are some property of intersection. Let A and B are two sets, then A intersection B equal to B intersection A, that is commutative property. Second one is associative property. Third one is law of identity. That means if we take the intersection of element of any set with respect to phi, we will always get phi. That means empty set. And intersection of any element with respect, intersection of any set with respect to itself will be the set again itself. And intersection of any set with respect to universal set will be the set again itself. This is called law of U. And this last one is the distribution law. Distributive law over here, the distributive law here, the intersection distribute over U. Here we have another example. Set A contains the element 1, 2, 3, 4, 5 and set B contains the element 2 and 3 and set T contains the element 4, 5, 1, 3, 7. And you have to verify A intersection B equal to B intersection A, that is commutative property of intersection. And second one is the associative property of intersection. So to solve the first problem, we have to find the A intersection B. So here this is the set A and this is the set B. So A intersection B will be the common element to both sets. So A intersection will be the set that contains the element 2 and 3. And similarly B intersection A, that means this will contain the common element to both sets, that is the common element to set A and B. So this will contain the same element, that is the 2 and 3 are the common element in A and B. So this will be 2 and 3. So hence we can say that A intersection B equal to B intersections A. That's the commutative property hold. Second, to solve the second problem, we find the intersection B, that is we are already find, that is that contains the element 2 and 3. After that we will take the intersection of A intersection B with respect to C. That means we will take the common element between A intersection B and C. So this is the A intersection B set and this is the set C. So the common element is only the element 3. So again we will find the intersection between A, B and C. So this is the set B and this is the set C. So the common element between B and C is the 3. Now we will find the intersection of this set B intersection C with respect to A. So that means we have to find the common element between the set A and the set B intersection C. So this set, the common element between these two sets is the only 3. So we can see here the A intersection with respect to B intersection C and A intersection B with respect to taking the intersection with respect to C, both are equals. Hence the associative property with respect to intersection is verified. Next is difference of two sets. So if A and B are two sets, then the difference of set A and B is the set of all those elements X such that X belongs to A but X does not belong to B, and denoted by A minus B, and read as A difference B. And mathematically A minus B is the set that contains X such that X belongs to A and X does not belong to B. Similarly, B minus A is the set that contains X such that X belongs to B but X does not belong to A. So B minus A is the set of those elements which belongs to B but does not belongs to A. So here is the example that is shown by the Venn diagram. The A contains the element 1, 2, 4, 3 and B contains the element 5, 6, 3, 4. So A minus B will be the set that contains all elements of A which belongs to A but not belongs to B. That is the elements of A which are not common to B. So that is 2 and 3 will be the only element which are element of A but not common to B. Similarly, B in B minus A, B contains the 4 element 3, 4, 5, 6. But B have in B minus A, B have to write down those element of B which are not common to A. That means which not belongs to A. So here 5 and 6 only two element which are the element of B but not belongs to A. So this is the definition of difference of two sets. Here is some examples. So this is the first example. The set A contains the element 2, 3 and 4 and set B contains the element 4, 5, 6. Then we have to find out the A minus B and B, A difference B and B difference A. So A difference B. So here A difference B will contains the element of A which belongs to A but not belongs to B. So here 2 and 3 belongs to A but does not belongs to B. So A minus B, A difference B will be the set containing the element 2 and 3. Similarly B minus A, so set B, B difference A will be the set that contains the element of B which belongs to A but not belongs to A. So here 5 and 6 belongs to B but does not belongs to A. So the set 5, the set which contains the 5 and 6 will be the set B difference A. Here is another example. Here the let here A contains, here set A contains the element 1, 2, 3 and set B contains the element 4, 5, 6. Then we have to prove that A difference B equal to and B difference equal to B. So A difference B, that is we have to write down the element of A which are not common to B. So here no element of A is common to B. So the element of A which are not common to B are 1, 2, 3. That means all the elements, sorry, the element, so the elements of A which are not common to B are 1, 2, 3. So this is the set A. So here 1, 2, 3 belongs to A but not, does not belongs to B. So the element 1, 2, 3 are the element of B minus A. Sorry. So element 1, 2, 3 are the element of A difference B. To find B difference A, we have to write down the element of B which does not belongs to A. So here A and B does not have no common element. So B difference A will be contains the element of B which does not belongs to A. That means B difference A contains the element 4, 5, 6. So B difference A contains the element 4, 5, 6. That is the set B. Next is complement of a set. The complement of a set A is defined as the set consisting of those elements of universal set which are not contained in given set A. It is denoted by symbol A dash. Symbolically, A dash equal is the set that contains X such that X belongs to U, X belongs to universal set and X does not belong to A. So this is the Venn diagram representation. In the shaded portion is given the A dash, that is these are the element of U which does not contain the element of A. So the element of A are given by the whitish in the circle, inside the circle in the white portion, and element of U, this is the entire, this is the entire set, but A dash will be the complement of A will be the element of U which does not belongs to A. That so the blue shaded portion is the A dash. Here are some examples. So first example is U contains the elements from 1 to 10 and A contains the element 2, 4, 6, 8 and 10. Then we have to find out the complement of A. So note that 1, 3, 5, 7, 9 are the only element of U which do not belongs to A. So 1, 3, 5, 9 belongs to U but not belongs to, that is 1 3 5 7 9 are the element of U which are not common to A. So the A complement will be the set containing the element 1 3 5 7 9. Another example is, let n be the set of all natural numbers be taken as universal set. So set of natural number will be taken as a universal set, and let A contains such that A contains x, x is even number, and x belongs to natural number. That means A contains the even natural number. Then we have to find out the complement of n. Sorry. Then we have to find out the complement of A. So here n is the set of natural number, that is n contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. And A contains even natural number, that means 2, 4, 5, sorry 2, 4, 6, 8, 10, 12 and so on. So complement of A will be the element of n which are not common to A. That means it will contain all the element of n which are not common to A. That means it will contain all the odd numbers, odd natural numbers. That means 1, 3, 5, 7, 9. So this is the exact exercise. First, define the union of sets with example. Second is, two sets are given, then you have to find out the union of A and B. Third one, two sets are given and you have to find the intersection of these sets. And third one, two sets are given and you have to find out the A difference B. These are some references from the material has been taken for this lecture. Thank you. Thank you everyone.